Okay, hi everyone. Today we are gonna look at one of the practice class writing examples. You can find it if you go to the main course page and go to practice problems all the way at the bottom. We're gonna select class writing and we're gonna work on the hot cocoa problem because it tackles a couple topics that I think will be helpful for your final. Um, well, mainly going to be working in VS Code, and I think it just helps break things down. I just copy and paste and then put into VS Code. Uh, and so you can work along with. I would definitely suggest handwriting it. Well, actually, no, because you guys are submitting digitally. If you are putting in your memory diagram, or your class writing in your final written out in Gradescope, I would definitely make sure you have figured out how to communicate indentation effectively. And if you are not able to, consider writing it by hand and submitting a photo for the section because indentation is very important in Python and also very important specifically for class writing. So. Cool. Let's get started. So when I tackle a class writing or any function writing problem, I like to break it down into chunks. I first like to read through the whole thing and then break it down into chunks and figure out how those chunks translate into uh, code. So let's get started. So we're going to create a class called. Oh, and I should specify that this example is kind of dependent on you having a semi-firm grasp of syntax. So, I'm not necessarily going to break down too much what a constructor is, or what attributes are, or what a magic method is. So, if you are struggling with some of that, I would consider pausing the video and going and looking at some of these videos, lecture videos, or even just the slides to refresh your memory. That will help a lot with going through this. So, cool. All right, so we are going to create a hot cocoa class, and we just think of it as like I would just think of it as this is a cup of hot cocoa. And what does hot cocoa have? Well, it has a couple things that make it a cup of cocoa, right? Well, first of all, it's a cup of hot cocoa, but it could also have a whipped cream. It could also have a flavor added to it. It could have some marshmallows on top, and if so, how many marshmallows? And it could have a desired sweetness. So these are the attributes uh, for each object of hot cocoa, each mug of hot cocoa that we're going to be making. So every single cup, every single object we create has to have a bool specifying whether it has whip, a flavor attribute, so whatever flavor that may be, raspberry, mint, what have you. And then how many marshmallows are on it and how sweet it is. Both of those are going to be integers. Uh, the class has to have a constructor, so when I see that, I know I need to make some sort of init method. Uh, cool. That sets up each of these attribute values. And I think at that point, we can get started. Some of these we will work on later, but we first need to create be able to have a way of creating this object. So first thing we will do is we will put in the syntax for starting it. So it's going to be called hot cocoa. And this starts the class definition. Lowercase c class, uppercase for the name of the class, colon. At this point, we have like kind of declared this class, and we need to list its attributes. So we tab in, so everything in the class definition is going to be tabbed in. So that includes attributes, that includes the constructor, any other methods, whether they be magic methods or not. As long as they are taking in self, they have to be indented inside of this class definition. So we got a couple attributes, right? We have has whip, which is of type stir. We have another attribute called flavor, which is also of type stir, and pardon me, has whip is a bool. So it's going to be either has whip or it does not. Cool. We got flavor, which is a stir. And then we have two integer attributes. One is called marshmallow count, which is going to be an int. And then we have a sweetness, which is also going to be an int. And that's it. These are all the attributes we need. If you are asked on an evaluation, hey, point out the attributes for the hot cocoa class. These are the lines they're going to be on for that. So cool. All right, let us start on with the next. So we need to create a constructor or the init method. This is the method that is what creates this hot cocoa object. So we start with keyword def and two underscores, or often called dunderscore, double underscore. And it's going to take in several parameters. It's going to take in something to define these four attributes, but it's also going to take in self. Now, self is what is actually being created here. This is when you look at a memory diagram. Let me pull up. So if we have stack heap, right? Now we're creating this hot cocoa object here, right? Hot cocoa. Pardon my. This is why I'm typing out this class definition, is because no one can really read my handwriting. So we have all our attributes right here, right, and their values over here. Now self is what's actually being created in the stack in this init method frame, and then we would give it an ID. So it's all getting created right here, but we have to tie it to the stack so we can use it elsewhere in the stack. Cool. All right, let's get back. So we have self, and then we have several attributes. I tend to just name the attributes or the arguments, or excuse me, the parameters for this in a method as the attributes of the class. So we'll go with has whip, and that is going to be a bool. We have flavor, which is going to be a stir. We have marshmallow count, which is also going to be, count, which is going to be an int. And then we have sweetness, which is going to be an integer. Now, this is the part of the signature that's going to look different from what you're used to. Magic methods, unlike any other function that you write, does not specify a return type. However, there is a return type for it, and there is a return value for it, and that is this self object that's being created. So when you are making a memory diagram, make sure that for the init method, your return type is going to be, or your value is going to be the value stored in this self slot in that frame. Cool. All right. So at this point, now we just need to assign these values that are passed in to the attributes of this hot cocoa class, or of this hot cocoa object. So we take the object self, dot, and then we access the attribute. Remember, to access attributes of an object, you first go with the name of the object. While inside of the method, we refer to it as self, and then dot the attribute aim. So self.hasWidth, we are assigning to the value passed into this method for hasWidth. Cool. And then we just kind of do the same for the rest. It's pretty simple. Flavor, set to flavor, self.marshmallow. It's going to be set to marshmallow. And self.sweetness is going to be set to sweetness. Cool. So just to reiterate, we have created a self object. We've accessed its hasWidth attribute and assigned it to the value passed in here. And we've done the same for all of these. Think of it as self.marshmallow accesses the marshmallow attribute and assigns to it the value passed into this to this function. Cool. So at that point, we are actually done with the constructor, so we can move right along. Now, we are asked, write a method called mallow_adder that takes in an int called mallows and increases the marshmallow count by that amount and increases the sweetness by that amount times 2. Cool. So when I look at this, I say, okay, I know I got to name this method mallow_adder. I know it's only going to take in one parameter, right? It's only going to have one parameter because it only takes in one argument. We're going to name that parameter mallows, and we're going to specify its type as an integer. So let's start there. We make sure we're indented underneath the class, and we say def, and we're naming it mallow_adder. And it's only taking in that one type. We're calling, or that one argument. So we're calling this parameter mallows, and it is of type int. Now let's look on increases mallow count, increases. So this direction says nothing about what it returns. So we're not trying to trick you here. There is no return type. So we specify none as our return type. Sorry. So we actually have to pass in self for this method. Mallow_adder is a method, so it is a function that is being called on a hot cocoa object. So it has to have as its first argument self, which is that object. Cool. All right, let's put some functionality in here. What does this parameter do to self? It increases the marshmallow count by that amount. Okay, so that's one thing. Marshmallow count is an attribute. So if we want to increase marshmallow count by this amount, we have to first access the marshmallow count attribute. So we first access the object, which inside of the method is self. And then we're going to access its the marshmallow count attribute. So marshmallow count attribute. And we're saying, okay, we're going to increase it by the amount passed in. So we can just do this handy dandy reassignment and plus equals mallows. Cool. So we got that. And now we're going to increase the sweetness by that amount times 2. Cool. So we need to access the sweetness attribute. So self.sweetness. And we're going to set it equal to the number associated with the marshmallow count, right? So we're going to add to the sweetness the number of marshmallows added times 2. So mallows times 2. Cool. At that point, we have finished the directions for this method, so we can move right along. All right. Write a stir magic method. Magic method, sweet. That displays, aka returns a string with, nice little hint there, the details of the hot cocoa order mimicking the following. So before I even read what it wants me to do, I know I have enough to create this function signature. It wants me to create a magic method. So I know it's a magic method means it has to have some underscores. And inside of those underscores, we're making a stir magic method. So we put stir there. It only takes one argument, which is self. And it was so kindly hinted to us that it is going to return a string. So there we go. Our type of return is going to be stir. Cool. So there is some subtlety here. So if it has whipped cream, we want to say a flavor, cocoa with whip, marshmallow count, marshmallows, and level sweetness, sweetness. If it doesn't have whipped cream, we want it to say all this fun stuff. Right in, let me move that up to separate these correctly. Cool. So we have two things that it wants us to do, depending on one attribute, right? Whipped cream. So that means we need some sort of conditional, right? If it has whipped cream, we want it to print out this, or we don't want it to print out this. We want it to return this string. If it doesn't have whipped cream, we want it to return this string. So that is two different options. So I know I'm going to probably want to use some sort of if-else statement. Now I know if has to be followed by something that evaluates down to a bool. Well, how useful? Haswhip is a bool, and we are putting a condition on what gets turned into a string based off of this bool whipped cream, has whipped cream. So if it has whipped cream, and if the hot cocoa object has whipped cream, it would be true. So all we really have to do is say, okay, if self dot has whip is true, so self dot has whip accesses this has whip attribute, which is either true or false. So if this evaluates down to true, then we want it to print all this fun stuff. So what do we want to print? We want it to, well, not print. I keep saying print. Please, 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 please. For a stir magic method, we are not printing anything inside of it. We're simply creating a string that we have decided this is how I want this object represented. So we, and then returning that string. So we want to return, right, the string, and this is where f strings are super useful because it makes everything a lot easier to type out. We want to return the f string a, and then we want to return we want to access the flavor. So we're going to say self dot flavor cocoa with whip. Then we want to access the marshmallow count. Self marshmallow count. And marshmallows. So we're accessing the marshmallow count. We're saying, okay, this has this let's say mint cocoa with whip, or a mint cocoa with whip, 7 marshmallows. Cool. This is just an example. Okay, so and level, and then we have to access its sweetness. Self dot sweetness. Sweetness. Cool. So if this has whipped cream, if this object that is passed into this stir has, if its attribute for has whip is true, then we want it to return this string to wherever the stir magic method was called. Otherwise, so if it doesn't have whip, excuse me, if it doesn't have whipped cream, if its has whip attribute is false, we want it to return this string. And I think we can just copy and paste a lot of this. It doesn't have a, oops. With, cool. All right. So, all right. So we have set up this conditional. If it has whip, it returns this string. Says with whip. If it doesn't, it returns this string. Says without whip. Cool. And that's kind of it for the stir magic method. We and this string will always be returned anytime the stir magic method is called. And keep in mind that the stir method is called if you call print on, say, some sort of hot cocoa object that we create. If we do that, it's first going to take this object and send it to self. You'll see it a little later when we actually instantiate some objects. Well, let's continue on. All right, write an order cost function. Cool. Don't even have to read further. I know a name for this function. So let's start with order cost. All right, it takes in as input a list of hot cocoa objects to represent an order. All right. Doesn't really specify what we name it, so let's get really creative here and call the parameter order. How about that? Cool. All right, and its type is going to be a list of hot cocoa objects. So list syntax for declaring type is going to be list, and then the types of elements populating it. In this case, hot cocoa objects. And returns the total cost of the order. Okay. Now, knee-jerk reaction would be, oh, cost, that's a number, so let's throw an integer in there. But if we read further, we can see that the cost is dependent on whether it has whip, and those look like floats to me. So that means we have to return a float. Why am I getting an error? Oh, gosh, dang it. Keep forgetting that. Sorry, y'all. Can't forget our self. Self always has to go into uh, oh boy. Okay. I messed up on the whole point of doing this problem, which is that we're writing an order cost function that is not a method. So this practice problem has specified when we look back Practice problem. It's a little hard to see when I'm putting it in the comments, but it's pretty apparent when you're actually reading it. So we've written all of these methods right here, right? You did a great job doing that. The last one says write an order cost function that takes in just the input list of hot cocoa objects, right? So this is not a method. And by not a method, I mean it's not actually called. Oops, wrong thing. It's not actually called on a hot cocoa object. It just involves hot cocoa objects. So because it's not a method, we no longer define it within the hot cocoa class definition. We actually have to come out here and say back into the furthest to the left indentation, globals, and say, all right, def, and we are naming it order cost. We decided to call it an order for the parameter and takes in as its argument a list of hot cocoa objects. There we go. That looks a lot better. And it returns a float. Cool. All right. Because I made that silly mistake, I really want to reiterate the fact that we were asked to make methods here, right? We were asked to make a mallow adder method. We were asked to make a magic method for the stir magic method. This asked us to create a function. Notice it's not asking us to change anything about a specific hot cocoa object. That's another clue that it's not going to be a method. It just is a function that involves this new class that we've created. And as such, it is going to be not indented underneath of the class definition. All right. So now we have built this definition. Now we need to figure out what to return. Well, we're just kind of trying to figure out the total cost of this order of hot cocoa, right? We have if there is whipped cream on the hot cocoa, it's going to be $2.50, and if it doesn't, it's going to be $2. Pretty simple, right? We don't have to worry about any of these other attributes. All I'm going to be accessing is has whip, right? Well, I need to sum up these numbers, right? I need to access them, right? I need to, at some point, like access a cocoa object, access its has whip attribute, and then depending on what its has whip attribute is, I either add $2.50 or $2. Well, if I'm going to be returning a sum total, I need to start somewhere, right? Let's pretend I have this list of hot cocoa objects and I have no idea how many are in them. I have no idea what they are. I just know I have to start at the top, work my way down and add objects. So at the very top, I am starting at a total cost of 0. Until I start seeing what they are, my total cost is going to be 0. So I'm going to create a local variable called total cost, and it's going to be a float, and it's going to just be set to 0, right? This is just a value that we can then store items as we sum them up. Now, next thing to do is figure out what to put into it. Well, I know I need to look at every single item, every single hot cocoa object in this list, but I'm creating a function that I want to be able to accommodate any order, right? And that means I need to accommodate an order of any size. And in order to do that, the only way I know how to look at every single item in in a data structure of indeterminate size is to create a loop. I need to create a loop so that regardless of the size of the list, I can look at every single one within this function. Because we're looking at every single object in this function or in this list, and we don't really care, we're not really removing anything, we're not really adding anything. I think the easiest way to do it is just to create a for loop. So for loop structure goes as follows. For, let's name it Cocoa, for every Cocoa. So for every Cocoa in order. So we're going to look at every single Cocoa starting on the first one in our list of hot cocos order. And what do we want to do? Well, if that cocoa that we're looking at has whipped cream on it, we want to add 250 to this total cost based off of our directions. So if, and we're accessing the has whip attribute, right? So if cocoa dot has whip, that's it, right? Like cocoa dot has whip evaluates down to a Boolean. So if it has whip, if there is whipped cream on this cocoa, it will evaluate down to true. So we will step into this if block if it is true. So and if it is true, we want to add 250 to our total cost. So we just say total cost plus equals 250. Now if it doesn't have whip on it, just like up here, we are kind of creating this else block, not kind of, we are absolutely creating this else block. And if it doesn't have whipped cream on it, we just add $2 to the total cost. So total cost plus equals $2. Cool. Now, let's see, are we done? We theoretically have started with a total cost of 0. We've looped through every single item in this order, this list of hot cocoa objects. For every single one, we've accessed the has whip attribute, and depending on what it is, we've either added $250 or $2 to the total cost, and then moved on to the next item until we've reached the very end. Once we've reached the very end, we have our total cost for this order, and so we just return what we were asked to return, which is total cost. Cool. All right. Now, the fun part. Let's practice instantiating this. We've created this nice little blueprint that helps us define what our hot cocoa object is. And we've also created a function that could, help a potential server at a restaurant, cocoa restaurant maybe, figure out how much to charge for their bill. So let's actually put this into practice in the real world. Let's create an instance of hot cocoa called my order with no whip. It has a vanilla flavor, it has 5 marshmallows, and it has a sweetness level of 2. And actually, I'm going to open off to the side here. Cool. So we need to create an instance of hot cocoa. Let's say, let's call it my drink. Right? We're creating a global variable called my drink. It's of type hot cocoa. And we are going to construct, we are going to initialize or initiate, or excuse me, instantiate this hot cocoa object. So what I'm doing is I'm actually calling the constructor for this. I'm calling the init method for this. but I can't. Python just doesn't really want you to just write init, right? Because there are. What if we had a pad thai class and uh, uh, a bread loaf class, right? They all have in them an init, so I can't really use this init method. I have to use the actual name of the class in order to call the constructor. So I say hot cocoa. And this is how I know the constructor is being called, the init method is being called, is that we have these two parentheses here indicating that we are making a function call, a method call, uh, and it is the name of the function that precedes these two parentheses is the name of the class. So that is what kind of tips us off that this is a constructor that we're calling. Now, this constructor needs some arguments, right? And they have spelled out those arguments for us. So let's get a little wild and do positional arguments for this function call. So we need it to have no whip. It needs vanilla as its flavor. It needs 5 marshmallows, and its sweetness level to be 2. Well, let's look over here at our init method. Its first argument, because remember we don't include self in the argument because self is being created. It has uh, four other arguments. Excuse me. So has whip is the bool, and we want it to have no whip. So our first argument is going to be false. Its next argument or parameter is flavor, which is a stir, and we've specified that we want the vanilla flavor. That is our second argument. Our third is going to be marshmallow count, and we've specified 5 marshmallows into an int, so just throw the int 5 there. And then the final one is going to be sweetness, which is also an int, and we have a level 2 sweetness. We have a sweet tooth. And that's it. We have done the equivalent. What we've essentially done is stack heap. We've called the init method. We passed in several parameters. One of them is going to be a hot cocoa object, right? It has several parameters. Maybe can I do this? Yeah. Hopefully y'all can see this. So it has several parameters. It has whip. It has flavor. It has marshmallow count. I'm just going to put marsh count. So on a test, you want to write out the full thing. Sweetness. Cool. So when we make this call, right, and pass in these arguments, the first thing I like to do is come over to the init method in a memory diagram and just build out these parameters first, right? So the first parameter to build is self. So I build the self. It doesn't have any values attached to it. That happens right here. So the next thing is to declare these other parameters, right? So we have has whip, we have flavor, we have marshmallow count. Again, I'm just kind of making space, kind of abbreviating, and then we have sweetness. Cool. Oh, don't forget return address. What is our return address? It's on the line that we're calling it on, right? We're calling hot cocoa on here, so 56 is our return address, and leave that return value slot blank. All right, so we have 4 other arguments. We have false for our has whip, vanilla for our flavor, 5 for our marshmallow count, and 2 for our sweetness. So we can assign has whip to be false, flavor to be vanilla. Notice the quotes were inside the stack. Marshmallow count is 5 and sweetness is 2. So cool. At this point, we can then step into the init method, and we're saying self.hasWhip is set to hasWhip. Now what this is saying is that self, well, the value stored at self is ID 0, so that takes us to the heap, right? And we're accessing the hasWhip, right? We're accessing this hasWhip attribute. So we're going self, takes us here, takes us to the hasWhip attribute, and we're setting it to the value stored in this hasWhip parameter, right? The argument that was passed into this parameter is now going to be taken and put right here based off of this assignment. So one last time, self.hasWhip is going to take in and assign to it this hasWhip value. So we assign false here. And then we kind of do the same with the rest. Self.flavor takes us to this slot, and we're assigning to it the value stored in this flavor. So vanilla. Cool. And then we do the same for marshmallow count and sweetness. So one last time, self.marshmallow count is set to the value stored at marshmallow count. So this is 5, and then finally 2 for sweetness. Cool. Now, are we done with this portion of the memory diagram? No. We still need to specify a return value. Now remember, at the beginning, when we were building this init, I said, there's something really weird about this. There's no return type specified. Normally, if there's no return type specified, you'd think, well, it's probably nothing, right? I don't see a return statement, so nothing gets returned. The init method is special. The init method returns self. Or in particular, the init method returns the value stored at self, right? It takes us back, it takes this value, this object that was created, and it gives us this reference point to it in the heap so that when we return to line 56, we can use this object we created. So the value that gets returned is the value stored at self. In this case, ID 0. Cool. All right, just wanted to do a little brief memory diagram for that. That one's pretty important. I just realized I forgot hashtag there. That's how we do it for memory diagrams with class. All right, cool. Now let's move on. We've instantiated this object. Now we need to add some whip. Right now we changed our mind. We want to add some whip. So we were changing whip. We're accessing the whip attribute or changing attributes with self, right? Because self is how it was accessed within this method. But we're outside of it, right? We've given a name to an actual hot cocoa object that has been created. In this case, my drink, right? And we want to directly access the has whip attribute. We want to change it. It's currently false. We want to change it to true. We just do that. We're accessing the values stored at the my drink object inside the my drink object and changing it to true. Cool. All right. Next is we're going to use our mallow adder object, so our method. So our mallow adder method gets called on the object that we want to manipulate. So my drink is the object we want to manipulate. We want to add 2 marshmallows using mallow adder. So mallow adder is our method name. Let's remind ourselves, mallow adder takes in 2 arguments. It takes in self and it takes in the amount of mallows we want to add. Well, I'm going to do something here and then explain why. Interesting, right? There's two parameters here, right? But I've only put 1 item inside of this these parentheses. Well, it's because the first item, the first parameter in mallow adder is the object it's getting called on. So there are 2 arguments here. Self just is attached with this period to the function call. And then the second argument is going to be the number of marshmallows we want to add. This directly takes us to this function. And at this point, we can, add the amount of marshmallows to self. Now, in this case, like self is the same idea as my drink. And so when we come back and move on to the next line, my drink is going to have 2 more marshmallows. All right. Let's create another hot cocoa instance called Victoria's Order with whip peppermint flavor 10 with whip peppermint flavor 10 marshmallows and a sweetness level of 2. Well, this isn't too bad. This is literally something we have already done. So we can pretty much copy and paste. We're going to change the name. So it was my drink. Let's call it Victoria's drink or order. Cool. It's going to be a hot cocoa object. This one does have whip, so this will be true. Peppermint is our flavor. And let's see what else. It has 10 marshmallows and a sweetness level of 2. Interesting. Twice as many marshmallows, same sweetness flavor. This is a wild world we live in. Okay. Okay. All right. So at this point, we want to calculate the cost of my order, Victoria's order, by calling order cost. Did I miss something? No. So we're basically going to want to invoke this order cost function. But first we need to create this list. Now, we needed my drink. Interesting. Cool. We need to create this list that we're going to pass into the order cost function. And we can either do that in 1 line, or I prefer to do it in 2, just to kind of wrap my head around to what's going on. So let's say we'll call it our order. It's going to be of type list of hot cocoa objects. And we're setting it equal to my order and Victoria's order. Right? This now creates a new object on the heap, and the values associated with the 0 index, the value associated with the 0 index, or stored at the 0 index, is the value stored in globals for my order, and the value stored in the first index is the value stored in globals for Victoria's order. Now those are going to be IDs. Cool. Now we're going to calculate the cost of those. in using the order cost. So we need to store it somehow. So we're going to say total, let's call it total cost. And is going to be a float. We're setting it to what happens when we call order cost with our order, this list of hot cocoa objects as its argument. We're going to store it there. The example is having me just kind of, I guess if we're running this whole thing, just doing this will return a total cost, which will just print out or show up in the terminal. So it should be good. Maybe. No. Okay. Moving on. Print out the details of the hot cocoa instance, my order. Now, print suggests I need to print something. So I'm going to start with that. Now, I want to print out the details of my order. Well, print calls the stir method. So essentially what we're doing is we're passing into print my order, which will invoke the stir magic method, create a string based off of whether or not I have marshmallows in my hot cocoa or not, and return that string to print, which then gets printed out in the terminal. All right. I believe that is it. And if yeah, cool. Yeah, if we run this file, we get it printing out vanilla cocoa with whip, 7 marshmallows, and 6 sweetness. All right. I hope this was helpful. Sorry about the little mix-up. Just remember to keep in mind that we had created three methods. One of them was a magic method, and then we created one function that was not a method. It wasn't getting called on an hot cocoa object. It just involved hot cocoa objects as its argument, a list of them, in fact. And then we instantiated a couple. We called the magic method down here for this print, and we accessed attributes or change attributes both directly or directly or using a method. So, all right. Please reach out over EdSTEM or via office hours if you have any questions. Happy to answer. Also, please take a look at some of the practice problems. They're a great way to practice. If you're looking at some of these questions and you're like, dang, this is really intense. This is a lot. You know, these are meant to help you practice. They're meant to kind of fill in gaps of memory or of learning. You're not necessarily going to get questions on the quiz or on the final that are going to be as intense. The final will be longer for sure than your quizzes, but it's not going to be as intense as these. Also, keep in mind, especially for some of these memory diagrams, along with the solution, there are video solutions that you can go to that have really they're similar to this, probably not as discombobulated and wordy as mine, but a great source of practice. So, all right. Thank you all, and good luck. Bye.